Hello, good afternoon, good evening, good night, or good morning, whatever it can be the case for everyone watching right now. Thank you, everybody, for watching. And I'm here one more time to show what I was waiting to show you the last time. The last time I did a video in Spanish, but now I am here to show you how to execute the or how to run the uh, ITABS models of a framed or RC framed compound of 10 flat or 10 floors or 10 levels, whatever way you can call it, doesn't matter. Okay, the reinforced concrete frame that I am showing you now is a is how can I tell you? I only okay this is this form part of a building of 10 floors, and I'm gonna show you how to review the pushover analysis on this software, okay, on this ETABS software that is a very very powerful software. Now I'm going to show you what I have now. I have done the previous calculation, that is um, the revisions or the reviewing for Eurocode 8 reviewings. Eurocode 8, Eurocode 8. Okay, so I'm going to show you this, and we have now some sections. Okay, these are not the real section, I guess. The real sections, we can see the real section in tables, and we are going to see this very quickly. So the real section that we do have are these ones. So we have for beams 700 depth and 400 width. And for columns, all these one are the beams, and all ones did I have only two kinds of columns. So it's the same section, but already has the a different reinforcement for each section. So these are the columns: 1.2 meters of depth and 7.7 of width. And the reinforcement for the columns are this one. The reinforcements are these ones. We have, okay, let me see, concrete column reinforcing. We do have here um for corner bar size 25 for the first or for the most under columns, and or the columns are situated all down, maybe the first fourth floors, and then the last one, the last columns from fifth to 10th, we have 16th corner bar size, and in in this other configuration appears over here. We do have numbers bars and the three direction, and number bars in two directions. So we do have all this, and we can proceed to do the check. So we continued doing the calculation of the concrete design, and we can see here that we can check that all our elements are passing the code reviewing. So we have design for um, we have assigned it to each or to all elements the DC law. So is according most all the rules that have appeared or have to be assigned to these frames. RC frame is most of the Eurocode 2, because Eurocode 2 it is only for the ductility class law. So that is very important to keep in mind. So we have already here defined the response functions for the seismic actions we are considering now, we do have this 20.5 g, the accelerations multiplied by the acceleration of gravity. We do have these ground accelerations, and this is the behavior factor that we are considering for the calculation of the elements. So we already, okay, there is a little message that appear uh, every time that every certain time that I need. I have already set it down the ETABS softwares in this way. So do you want to save your model now? Yes, of course. Okay, now we do have this PM's interaction radio call for columns. So we need to check the reinforcement. Well, okay, first we have seen here that all my element has passed for PMM's interaction radio, and we don't have any failures. So all our elements are passed, and we need to check the total reverse percentage in every element. So this is very important to do before doing the performance or the pushover analysis. So now we have all these. We can proceed to do the analysis or for the nonlinear static analysis for nonlinear static actions. And we have two kind of action. That is what the Eurocode 8 require for doing calculation of pushover analysis. So we have one for a force, and we have one for a modal move. So this is very important to keep in mind. So we are going to get two pushover curvatures. So we have already run all this because this is the column that indicate the action of the actual set lot case to run. So all these actions are run right now. So we do not need to do anything here. So we can display it over here, the static pushover curve. So we have here the base shears versus monitor displacement in the horizontal axis. We do have the monitor displacement. The vertical axis, we have the base shears. So that is very important. And so now we are going to consider the Eurocode 8 2004 target displacement. This is the Eurocode 8 method to verify or to check the, the behavior of the pushover analysis of the building. So we can select this one, and you can remember that our acceleration over here is point 25. So that is very important, and we can put here the behavior factors Q, that it is always for pushover analysis is one. It's always, no matter how you can define how you already find the accelerations force for the earthquakes find. So we can check over here all the data obtained that are the displacement. First place are 91 millimeters. Fourth, the target displacement, and the shear the target displacement is this amount of newtons. It is in newton. You can divide by 1000, and we can see that is 2.547 kilonewtons. So that is the shear force at the displacements, the target displacement. So this is very important to get in mind. So but we can't go further into one more step, that is applying this ground acceleration for 0.6 13.339. I don't I get that is the right one day I'm going to show you how to get why I am multiplying this, because Um, point 25, this is the seismic that is for mm, that has to be in the elastic or not in the elastic. It has to be in the range of an elastic curvature. So if we want to see the action in the inelastic actions, inelastic curve, we can't multiply this for this factor. So we can see that the displacement limit is accordingly to the displacement of the structure. For instance, we need 60 degrees, sorry, 60 millimeters as a limitation for the Eurocode 8. That is what Eurocode 8 permit for, or it is allowed for 3 meters columns of interstory. So that is very important. So we can multiply it, and there is a formula, a formulation in Eurocode 8 that shows you how to check this. Um, mm, I don't know how to say this in English. The deriva is in español. The deriva or displacements limit, or desplome en español, no? That, this is what the Eurocode 8 allow it for a interstory limit of 3 meters height. So we have over here that we have verified this limitation, and we can't I can show you, or I can show you in the description of this video on YouTube, where can I get where we can get this deriva. But you can search it for yourself in Eurocode. So we have fulfilled the limitation, the target. Okay, the target displacement for the equivalent yield displacement. Okay, all these limits are all these factors are to verify or to transform the structure, the multi-degree structure into one degree structure, so into one single degree system. So and then one more time they come back and do the transformation back to the multi-degree of, of freedom system. So we are showing here for one multi-degree of freedoms, and it is not for all the multi-story, but is one multi-degree equivalent, as it is shown here. The equivalent yield displacement is this one, and this is the for all the structure. Okay, so all this displacement is for all for the multi-degree of freedom, and this one is for the equivalent yield displacement. So this is the 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 target the sorry the pushover curve. So we can see over here is the deformation that occurs once we have uh, the result. So we can, for instance, type 50 here, and we have 16 steps. We can apply and we can see um, what hinges are showing more stresses. And if we reduce the steps, we can see how this is accommodating to the first step. So you can see all as there the code requires the beans have to be the first one into fail, into getting in failed. So this is what is happening here. So in the step 10, and we can explore even more. But as for now, this is the finish of this video, and I hope you can enjoy it and learn a lot. Thank you so much for watching, and see you See you back again in one another video. Thank you guys. See you.